Hello, everyone. This is Mrs. McMill. Sorry, I am not here today, but I'm hoping that this can help you guys learn even though I'm not there. Everyone needs to get out their notes and turn to page 19. I'll wait a second if you haven't already done that. And we're going to learn two more sets of properties today. The first set's called the double argument properties, and the second set is called the half argument properties. So first we're going to find the double argument. And goal number one is to find the formula for sine of 2a. So see how it's the double of a? So what you want to do is actually use your sum difference. So you think, okay, sine of 2a is the same thing as sine of a plus a. And then you use your chance. So what's our chant for sine? Sine, cosine, cosine, sine. So we have sine of a, cosine of a, cosine of a, sine of a. Notice if you switch the order, you really have two of the exact same thing, okay? So then you have 2 sine of a, cosine of a. So that is our property. This double argument for sine is 2 sine of a, cosine of a, okay? The next one we're going to do is find a formula for cosine of 2a. And we're going to start the same way. We're going to remember that a plus a is 2a. And then the chant for cosine is cosine, cosine, sine, sine. So hopefully you see cosine of a times cosine of a is cosine squared of a. And sine of a times sine of a is sine squared of a. So that is one way we have a double argument for cosine. Now, because of the Pythagorean, there's actually 3 versions of the double argument for cosine. So if you use the one we just found, you can substitute for cosine squared of a with 1 minus sine squared of a. And then notice we've got 2 negative sine squareds of a, so it's 1 minus 2 sine squared of a. So that's the second form. This sheet doesn't show. There we go. Both of them. There's the 2 we have so far. And then there's actually a third one, but you start back with that first one we found. And this time, instead of substituting for cosine squared of a, you substitute for sine squared of a using Pythagorean. And you need to make sure you distribute that 1 properly. So it's going to be minus a negative cosine squared. So it's going to be plus cosine squared. And then you combine like terms, and you have 2 cosine squared of a. So there are all 3 of the double arguments for cosine. You're really going to want to memorize all 3 eventually. Okay, so now we are going to find the double argument for tangent. So same idea. We know 2a is a plus a, and our chant for tangent is tan, tan, 1 tan, tan. And if you notice, we have tangent of a plus tangent of a. So that's going to be 2 tangent of a. And then in the denominator, we've got tangent of a times tangent of a. So that's going to be 1 minus tangent squared of a. And that's actually it. That is your double argument for tangent. So there are all of our double argument properties. And you guys will use these a lot. Okay? So definitely put them to memory soon. And then now we're going to talk about the half angle properties. These ones you don't use quite as often, but you do use them. Let me actually put this screen on so we can kind of talk about what's going on. So to find the double argument, to find the half argument for cosine, you actually start with thinking about it as a double. So cosine of 1a, hopefully you realize 1 is the same thing as 2 times a half. So now we've got the double argument of 1/2 a. So you use the double argument property, one of them, for cosine. And look, I'm using the one with sine because I'm going to first of all find a formula for the half argument for sine. So it's 1 minus 2 sine squared of 1/2 a. And then you move things around and you end up with this. And now we're going to divide by -2 and take the square root of both sides because we have a sine squared and we want a sine. And don't forget, when you take the square root of both sides, you have to do plus or minus. And so then we get this. So that is our half argument for sine. Now, the form you guys have on your notes, instead of it being all over 2, it has the 1/2 as a coefficient. Either way is fine, whichever way you're comfortable with. Okay. Now, I'm not going to go through all the derivation of all the other ones, but you guys have all of the half arguments on your paper for sine, cosine, and tangent. And again, here's how on your notes, you have the 1/2 in front, but you could also have all over 2, whatever you're more comfortable with. And notice there are 3 versions of sine. three versions of tangent. You will need to get all those memorized eventually. Now what we're going to do is use these new properties, the half argument properties and the double argument properties, and learn how to apply them. So you're going to have these problems where they say, find sine of 2 theta, find cosine of 2 theta, find sine of theta over 2 or 1/2 theta, and find cosine of 1/2 theta. So the original problem in this first problem, they tell us the sine of theta is 3/5. They also tell us that theta is less than pi, but greater than pi over 2. So that tells me it's in the second quadrant. So what you want to do is draw your angle with the triangle in the second quadrant. Now we're told that sine is 3/5. Remember that sine is y over r. So we know our y value is 3 and our r value is 5. Hopefully you realize this is a 3, 4, 5 triangle, but because the x value goes to the left, we know that's going to be a -4. From here, you just need to figure out the sine of theta and the cosine of theta. Of course, you were already given the sine of theta is 3/5, and then the cosine of theta is just going to be -4/5. The other thing you need to figure out is half theta. Because if you look at your half argument properties for sine, cosine, and tangent, at least one of the tangents, they have a plus or minus. And the plus or minus, you have to figure out, is it going to be positive or negative? So the way you do that is you have to figure out where is theta over 2. So right now, half theta. Right now, theta is in the second quadrant. So we're told theta is between pi over 2 and pi. So all you want to do is take half of that. So if you, let me make this a little smaller. If you take half of pi over 2 and half of pi, you get that theta over 2 is between pi over 4 and pi over 2. So if it's between pi over 4 and pi over 2, realize that pi over 4 is in the first quadrant. So right about here. And pi over 2 is here. So this region right here is where half theta is going to be. So that's the first quadrant. So because it's in the first quadrant, you know that everything's going to be positive because sine, cosine, tangent, everything is positive in the first quadrant. So that's what you need to figure out with those. Let me move on to the next page. Okay, so here's the first problem. First part of the first problem. It says find sine of 2 theta. So you look at your double argument for sine. I highly suggest writing it down without any numbers in it first. And that's 2 sine of theta, cosine of theta. And then you already know sine of theta and you already know cosine of theta. So you just substitute those values. And then multiply it all out. And you get -24 over 25. Maybe I went a little fast. I'll give you time to write that down. The next one is cosine of 2 theta. And cosine of 2 theta has 3 different arguments. You can choose any one you like. It's usually easier, I think, to choose one that only has one trig function. That first one has cosine squared minus sine squared. So I'm going to use this one, 1 minus 2 sine squared. Now be careful, this is a sine squared. So sine of theta is 3/5. So when you substitute that, make sure it's 2 times 3/5 quantity squared. Okay, and then multiply all that out. 3/5 squared is 9/25. And then you're going to subtract those and you're going to get 7/25. So those are 2 double. The double ones are easier, I think. Now for the half, finding the sine of half theta. Now remember, back at the beginning, we found out where the half angle lies. So remember, this is the formula, the half angle formula for half angle of sine, and it has this plus or minus. So you have to be careful and think, is it going to be positive or negative? Well, remember, we found out that it's in the first quadrant. And so that means the sign is going to be positive. So you only need your formula with the positive sign. So now that you have your formula only with the positive sign, you plug in the values. Remember that cosine is -4/5. So you plug it in and you simplify it. And then the next step, you just know, okay, minus and minus can be plus, and then the common denominator is 5. So I turn the 1 into 5/5. And then 5/5 plus 4/5 is 9/5. So now we have 1/2 times 9/5. So that is the square root of 9/10. Well, 9 is a perfect square. So you separate to be the square root of 9 over the square root of 10. And then it ends up being 3 over root 10. And then you rationalize it. And the sine of 1/2 theta is 3 root 10 over 10. Again, that's positive because it's in the first quadrant. Now we're going to do the same thing for half angle of cosine. And you first of all, you want to write down the formula without anything substituted. That's a good key to success. And you still should remember that we found out in the first that it's in the first quadrant. Oh, and I should have fixed this. This says, so sine is positive. It should say cosine is positive. But everything's really positive. Okay, and let me cross that out. So we mean cosine is positive. So you can rewrite your plus or minus symbol without the plus or minus because we know it's positive. And then you plug in the values. Cosine of theta is -4/5. And then when you simplify this one, you get the square root of 1/10. And again, 1's a perfect square. And then you rationalize it, you're going to get square root 10 over 10. That's it for the video portion of the notes. To the substitute, would you please now pass out the sheet titled 7.5 Day 1 Notes? Students, you should use this paper to finish your 7.5 Day 1 notes. After you finish the notes, please get started on the assignment. It's written at the bottom of the back of the sheet that the substitute is passing out to you. To the substitute, please also let the students work together and please let them have their phones out. The video notes are online. They could look at it again. They can also check their answers to the problems, and the book problems are also online. Students are also more than welcome to get a book. I will be collecting homeworks 9 and 10 on Friday, so please be prepared. And again, the quiz is canceled. Have a good day, and I will see you Friday.